Welcome. The Passive Sampling Technology Update team is proud to present an overview of diffuse gradients in thin films passive sampling technology. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document. The Diffuse Gradients in Thin Films Passive Sampler, or DGT, is an accumulation-type passive sampler. DGT samplers can be used in surface water, groundwater, sediment pore water, and saturated soil. The device operates using the principles of molecular diffusion across a membrane filter and diffusive gel, and is then absorbed by the binding gel at a controlled rate. The binding agent should have a high affinity and capacity for the target analyte, so that diffusion becomes the limiting step in the accumulation process. Therefore, a concentration gradient exists between the compounds in the target aqueous media and the binding gel. The technique uses a hydrogel layer to control the diffusive transport of the target analytes in solution to a cation exchange resin. The DGT sampler works by sampling a concentration of target chemicals, easily broken down in solution, so that it may be calculated using the following: the measured target chemicals on the resin, the sampler exposure time, and the temperature-corrected molecular diffusion coefficient for the target chemical of interest. The technique was first used to detect metal cations in marine environments. The DGT sampler has been modified and expanded to include a significant number of elements and chemicals, including cationic and anionic or neutral oxoanionic metals, organic substances, inorganic nutrients, antibiotics, bisphenol, and nanoparticles, and radionuclides in different media. DGT samplers are available in two configurations: a sphere or flat DGT sampler for use in sediment and soil, a piston or disc DGT sampler for aqueous environments. The DGT sampler includes the following parts: the DGT base, a binding membrane which is required for some applications, the resin gel, the diffusive gel with a known thickness, the filter membrane with 0.45 micrometer pore size, and the DGT cap or housing. Let's look at the steps and some considerations for DGT assembly. Select the applicable gels and membrane filters, which are based on chemical and media targeted for sampling. Stack the resin and diffusive gels on top of each other between the membranes into the DGT housing or DGT base and cap assembly. Store the assembled devices hydrated with deionized water at room temperature or refrigerated in airtight bags containing applicable sampling preservative. The device requires deoxygenation prior to use because dissolved oxygen in the diffusion hydrogel and binding gel can influence the speciation of redox-sensitive chemicals. After deoxygenation, the device should be carefully shipped in sealed oxygen barrier bags on ice in a cooler to the site. The dimensions of the gel layers vary depending on features of the environment, such as the flow rate of water being sampled. Deployment of the DGT device typically involves suspension of the sampler in situ or in a stirred solution in the laboratory or in the field for a fixed period of time, typically ranging between 1 to 24 hours. The DGT deployment time should be carefully determined and consider the following factors. Deployment time should be sufficiently long enough to accumulate target chemicals in the binding gel, but short enough to avoid the saturation of the binding gel. The sampler should be deployed as soon as possible after taking out from oxygen barrier bags to minimize the introduction of oxygen into the device. Deployment duration, temperature, pH, and salinity of the aqueous media are recorded by field personnel during both deployment and retrieval. Here are some considerations for deploying DGT samplers to soil. Smear a thin layer of soil onto the DGT filter surface. Press the DGT device onto the soil surface using a twisting motion to ensure good contact with soil and DGT front filter membrane. Cover the DGT device in soil using a clean plastic sheet to avoid evaporation. For deployment into water, follow the following steps. Place the DGT sampler in the plastic holder, or attach the sampler through the hole on the device rim using a thin line. Deploy the passive sampler immediately after opening. Ensure that the white face of the DGT unit is fully immersed in water during the entire deployment period. When deploying to surface water, avoid excessive turbulent flow, and to fix the DGT device to a firm point. Here are steps to keep in mind when retrieving a DGT samplers in soil. When removing the sampler from the soil, take care not to touch the face filter membrane. Rinse the DGT device with a wash bottle stream of deionized water, and dry obvious surface water with a clean tissue. When retrieving the device from water, here are some steps to keep in mind. On retrieval off of the holder, remove the DGT sampler immediately, taking care not to touch the face filter. Rinse the sampler with a wash bottle stream of deionized water, and shake off obvious surface water. Do not dry the sampler and place in an airtight bag. Upon retrieval, the rinsed DGT device is refrigerated in sealed plastic bags to avoid dehydration and potential contamination from the air. When preparing the DGT sampler for shipment to the laboratory, disassemble the DGT sampler and remove the filter membrane and diffusive gel layer. Extract the resin-binding gel layer and place in a clean sample tube with appropriate preservative. The sample should rest for at least 24 hours before analysis. Extract and analyze for the target chemicals content by either typical laboratory analysis via extraction and mass spectrometry, or through direct analysis of the resin. Some of the advantages of the DGT sampler include: the device can be custom-made from the manufacturer to meet project-specific goals. The sampler is easy to deploy and retrieve. The DGT sampler allows for in situ evaluation of label fractions of target analytes, and the device can measure a wide range of chemical concentrations. Some of the limitations include: longer deployment time may cause saturation of binding gel, which may result in biased results. The device needs to be deoxygenated to reduce introduction of oxygen into reducing environments. Accuracy of calculated concentrations depends on knowledge of diffusion coefficients in the hydrogel, which may not be known for certain chemicals. For more information on the DGT sampler and other passive sampling technologies, check out the ITRC Passive Sampling Update web guidance.